right, welcome class. Today we are learning about 6-3 and we're going to determine the number of solutions. The learning intentions today is that, to be able to determine the number of solutions to a system of equations, and you know you got it when you can determine if there is one solution, no solutions, or infinite solutions for your system. So let's take a look and see what that entails. So here are your three cases. You have no solution. When there is no solution, you have parallel lines, all right, which means your lines will never touch. So if your graphs don't touch, well, they share no solution. Second case is they are essentially the same line, and by essentially, I mean they are the same line. If that is the case, you will only see one line, and that will be infinite solutions. So if you see two equations, but you only see one line, that means they are the same line and there are infinite solutions. Going over here, both of these are the same case. Both of these have one solution. So if you have lines that just intersect because they have different slopes and a different y-intercept, then the one solution will be where they intersect, where they crisscross. In the same vein, if you have different slopes but same y-intercept, well, they still have one solution, and that one solution is where they cross, but where they cross would be your y-intercept. So your one solution would just be the y-intercept. I don't think we have an example of that, but basically that would be something, I'll get to that later, don't worry about it. Let's keep going. So the nice thing about this unit, or this section, for section 6.3, you don't have to graph. They give you the equations, and they already give you the pictures that are graphed. And they tell you which line goes with which equation. All you have to do is tell me, is there one solution, no solutions, or infinite solutions? You do not even have to tell me what the solution is yet. That's next section. Right now, you just say how many there are. So let's take a look at this. We have two lines. They crisscross right here. So they have one solution. Let's check out the next one. Just kidding, real quick. This is the long explanation written down of why this is one solution. If you would like to, pause this, read it, write it, whatever you need. I'm going to move on to the check problem. All right, so you have your two graphs, you have your two equations. Just tell me how many solutions are here. Pause it if you need to. Next is going to be the answer, so pause, try it on your own, then on pause, take a look at the answer. Obviously, once again, they intersect right here, so they have one solution, all right? Let's go to the next one. All right, here once again, we have two equations. The equations have different slope, or the same slope, but different intercepts. That should tell you that they're going to be parallel. If you don't remember that, literally look at the graph and see that they will never touch. There is always space between the graphs, which means they have no solutions. All right, once again, this is the long explanation. Feel free to pause and look at it if you need to. All right, so this is a check problem for you guys. Just try to solve it on your own. Pause it here. The answer's on the next slide. Hit resume if you need to see the answer. Once again, you can see here, no solution. All right, so this is your final example. Once again, you have two equations in your system, and when you graph them, they happen to be the same line. Because they are the same line, you have infinite solutions. Easy as can be. All right, next slide is going to be the same stuff with written. You can pause it, write it if you need to. If not, just skip forward to the check problem. Try it on your own. Once again, here's that long-winded explanation. You may pause it and copy what you need to, and then move on to the check problem. All right, y'all, this is your final check problem. Once again, try it on your own, pause it, answers on the next slide. These are it for your notes. Have a good day. See you on Monday.